Welcome back to the Tech Between Us. We'd like to continue our conversation on green energy storage systems with Dr. Imre Gyuk, Director of Energy Storage Research at the U.S. Department of Energy Office of Electricity. This is part 2 of our discussion on this topic. To hear what you missed about green energy storage systems, visit the Tech Between Us page and get caught up on part 1. So, let's shift technical gears and talk about an innovation relatively new in Mouser's world of semiconductor components, wide bandgap semiconductors. Is that an area that the DOE has researched, and where do you see these devices taking energy storage systems?
Well, we became aware of wide bandgap semiconductors quite early in the game, almost at the same time that we started doing energy storage in general.
Okay, so going on 20, 30 years now then.
Yeah, exactly. You know, we worked with silicon carbide first, and now we're into gallium. We worked basically on switches and then incorporating the switches into bigger devices. And you have a number of options there. I mean, one of the things is to have integrated devices where you make the paths of the electrons as short as possible. You can get things very fast and with fewer glitches.
Right, minimizing all the parasitics along the way.
Yeah, and you know, we've been very successful in at least producing prototypes of these things, and many of the small companies, well, a number of the small companies that we have worked with in developing these devices have since become bigger and then eventually have been bought up by larger companies.
Right.
And they're now part of the commercial world.
So, I mean, wide bandgap, silicon carbide and gallium nitride are, huge for many of our suppliers in targeting both EV and green energy applications, especially for the larger inverters and whatnot.
Because they're so much smaller, you gain fantastically on footprint by about a factor of 10. Particularly when you build a big facility with thousands of batteries in it. You can't afford big devices there to do the connection between the batteries and the outside.
Right. And that goes back to your discussion about infrastructure. The more we can minimize the infrastructure and the space and the heat, the better the overall system works.
Right.
Silicon is still being primarily used in energy storage. Do you see wide bandgap really changing that whole landscape?
Well, it changes the inside. I wouldn't say that it drives the storage industry. It's just one of those things that you need to do because it's like walking with an ill-fitting pair of shoes.
Love that.
We are looking into other devices such as soft magnetics for transformers, and new bandgap technologies like aluminum and boron nitrides, and eventually diamonds.
Yeah, I've read about that. That will be interesting.
Yeah.
Now, how promising does that look, and how far out do you think, any of these newer, the boron technology, and especially diamond, how far out do you think that's going to be?
Diamond is far out.
Right.
Boron is beginning to happen.
Okay. So based on similar timelines from when you started investigating silicon carbide, so probably another decade or two then, it sounds like.
Yeah, could be. But again, as we have more and more concentrate on electric vehicles and storage, the market is bigger for these things.
Right. Yeah. I mean, obviously the EV market especially is exploding. And if we are to go to decarbonizing and carbon neutral, obviously renewables and green energy has got to continue.
Quite.
Right. And probably double, triple, quadruple in size.
Yeah. Exponential.
Right. Absolutely. What other device technologies should we be keeping an eye on? I mean, you mentioned soft magnetics. What else are you guys looking at that has the potential to be a game changer?
Well, actually, as I mentioned, aluminum and boron nitrides. We are taking our power electronics step by step because basically the funding is considerably less than the funding in energy storage itself. As a matter of fact, I have been carrying the power electronics, essentially because it's something I like and because I can set a little bit of funding aside for developing it.
And obviously, as Mauser, as an electronics component company, that's where our focus is, in the power electronics, working with our suppliers to make sure their newest silicon carbide, gallium nitride products get to market and are available to customers, to engineers to design in.
Yeah, it's essential.
I mean, I look forward to seeing kind of what comes out of the labs on that front. I've kind of read, about some of these technologies, and I'm glad to hear that they are, some of them are beginning to move forward.
Yeah.
We've talked a lot about the technology behind energy storage systems, but obviously it all comes down to real-world deployments and applications for energy storage. From an overall standpoint, how does your office in the DOE, how do you prioritize between technology research and actual real-world deployment?
Well, we produce a new materials technology, or we find that other people have found technology successful, and then we try to support them by partnering with, anybody to actually build something. And our guideline there is, whenever we get involved in a partnership to build something, it's got to be something innovative and new. There's no point in supporting yet another lithium-ion facility. It's got to be something new. Either the materials have to be new, or the financial structure has to be new, or the application has to be new.
So you're always looking to push some sort of innovation, either in a materials or a device, or even like we were talking about regulation, finance,
exactly,
and infrastructure, any of those.
Yeah.
So things got to be constantly moving forward.
Actually, the first thing that we got involved in was substation upgrade.
Okay.
If a substation isn't up to it anymore because the load has become too big, you have to upgrade it.
Right.
And upgrading is very expensive because essentially you have to just build a bigger one.
Right. And a lot of the substations are in the middle of cities, surrounded by neighborhoods and developments and regulations.
But if you pair the substation with storage to take care of the extra load, then you can do it in a modular way. You can keep adding storage or taking it away if the load becomes less, which does happen. And so you get much more flexibility in your substation upgrade or development. However, that was not the first serious application of storage. We built a few of those, but they weren't quite cost effective.
Okay.
So we hit upon something new, and that was frequency regulation.
Oh, really? What's that?
Well, frequency regulation is basically the grid continually jitters.
Right. I
think it's switched on and off and on and off.
Right. Yeah. The constantly load is changing.
Yeah. So you have to smooth it.
Okay.
Or if you have a lot of photovoltaics on it, if you have a cloud coming past, you have to go over that.
Right.
And it's done by changing the frequency, but let's not go into that. Okay. But the point is, it's something you have to do. And the way it used to be done traditionally was that you reserve a little bit of extra energy, say 10% on your generation, so that you can go up and down. If you have storage, you don't have to do that anymore. The storage takes care of the fluctuations on the grid, short-term fluctuations, like 15 minutes to half an hour or so.
So in electronic terms, it's almost like your storage facility becomes a capacitor.
Right. And that hit home. That worked, and it profited. It was the first economically viable technology for a technology application for energy storage. And, as soon as we demonstrated that, and I should mention that we demonstrated it in company with both the California Energy Commission and New York State Energy Development. Those were our partners in that, and we showed that it could pay off, And once we did that, frequency regulation plants came up like mushrooms. Everybody did one until basically there was enough frequency regulation so that you couldn't really make much money putting in a new one.
So the landscape became saturated in terms of frequency regulation facilities.
Yeah, but that showed the utility industry that they needed storage, that storage was going to feature as an item on their future grid. And then the next one was solar plus storage. And we showed that solar plus storage works much better than solar alone, because if you do solar alone, you get only about 20% as a safe bet.
Right.
You know, it's not dispatchable. But with storage, the solar becomes dispatchable, and that became commercially viable.
Is that pretty much standard deployment now? You don't deploy a new solar facility or add on to a solar facility without the corresponding storage system?
It's becoming almost standard.
Right. Yeah, I would think so. Once again, just logically thinking it through, like you said, the sun doesn't shine all the time, and yet people are going to need energy all the time.
And the more photovoltaics you have, the more storage you will need.
Right. And it just builds and builds and builds.
Yeah, and at the same time, the regulatory structure has to build. At the moment, only half of our states actually have regulatory structure in place.
That's interesting. I would have never guessed that. I would have thought that's just part of business.
Yeah, well, most of the middle of the country is doing business as usual, and they have not gotten to developing a regulatory structure which can accommodate this new element of storage. Although if you're a wise utility, you will work with it so that you're ready when you do need it.
The source is free. You think that would be a no-brainer?
Yeah.
Renewable energy, in addition to storage systems, are really changing the way we look at the grid, the way we look at society in general. Long term, where do you see renewable energy really benefiting society in a major way?
Well, the first thing we have to do in terms of storage is we have to get ready for more and more renewable energy. And that means the total decarbonization, which means we have to store energy for the vehicles, for agriculture, for buildings, wherever the renewable energy is going to be used. And that's quite a load. So we have to not only have short-term storage. See, frequency regulation, you can get away with an hour or two, and most of the solar plus storage is about 4 hours. But once we have serious solar, it's going to be overnight. You need 12 hours.
Okay, 12 hours of potential storage capability.
Exactly.
All right.
And yeah, but what if the sun doesn't shine for a day or two? Then we need backup, and there we need about 3 days. You know, and so the aim at the moment, the big aim, is to develop long duration storage, because lithium ion is really good only for 4 hours. So we don't have a real need as yet, but we know it's coming. And we have to develop long duration storage. The other direction we can go in, of course, is we have to look at that part of the population that does not have easy access to electricity. And that's our disadvantaged population, or underserved is the word one uses. And that's becoming a big issue nowadays, because we have realized that we can't go ahead with half the population or any population being underserved. And so we work on that.
Have you done projects around specifically targeting underserved populations and helping them, bringing them onto the grid?
Yeah, most definitely. Actually, we have had projects with underdeveloped societies for quite a while. We work with tribes
Okay.
We have a high school in Albuquerque that mostly serves Hispanic population, where we installed a storage plus photovoltaics. Mm-hmm. And the point is, if you make a high school more independent, then that place can serve the population in case of emergencies. It becomes a center where people can go and feel safe and
that's
have,
interesting.
And have electricity.
Right. Absolutely. I live downtown, and, I take it for granted, but, especially out in more rural areas, that may not be the case.
Yeah. So we have rural populations, we have disadvantaged urban populations, mm-hmm. and we have tribals. And because we saw this need, we started a project called Energy Storage for Social Equity.
Okay, terrific.
ES4SE. And what we have done is we have, by sending out a request for proposals, we started with 60 proposals. We cut them down to 14. Mm-hmm. And we took those 14 communities and gave them intensive training for 1 year, exploring how energy storage could help them.
Right. Okay.
And there's a lot of things that a community cannot really do on their own. And that's dealing with all the interconnections to utilities, mm-hmm. dealing with the municipality, if there is one there, making sure that you're not building on marshland and going against code that way. So we work with them and we get them around all of those things and try to explore how energy storage could help them. And now that they've had this preparation for a year from Pacific Northwest Laboratories, my team at Sandia will take over and will actually partner with them and build a storage facility that fits their needs.
So not only do you do the education and the support for municipalities and regulation, your team, one of the national labs, actually goes out and builds it and installs the facility for them.
Well, we don't actually install it. We help them hire a contractor. We help them with the specs, and we help them with making sure that they're getting their money's worth and that it works after it's built.
Terrific. So once again, from soup to nuts, from the beginning all the way through the end, helping the tribes make sure that nobody lives in an energy desert.
Yeah, exactly. Energy desert. I mean, poorer population have more outages, and the outages take longer to mitigate than more affluent communities.
Right.
I mean, think of Puerto Rico. In the central mountain districts of Puerto Rico, there are still people who are out of electricity after the 3 big hurricanes.
I read that after the most recent hurricane that they hadn't even rebuilt from the one before.
Right.
Yeah, that's scary. I cannot imagine not having reliable electricity for that length of time.
So we have a project in Puerto Rico as well.
That's terrific. So true change within society as a result of technology and energy storage and renewables. Let's take a look at a noteworthy innovation with our next question that comes from our sponsored partner Panasonic, who is providing cutting-edge components for engineering solutions worldwide. Explore more from them by visiting mauser.com/Panasonic. As I'm sure you're well aware, the fusion research team at Lawrence Livermore recently announced achieving net energy gain through the fusion process. And I know it's decades and probably tens of billions of dollars away from commercialization, but where do you see fusion and renewables coexisting in the future to provide clean, relatively inexpensive energy for the entire globe?
Well, that proof that we can control fusion has been very elusive for a long time.
Absolutely.
It was always 10 years from now. But we now have that proof. It's a fantastic accomplishment. That we can produce net energy by fusion, if only for a short time.
Right.
Now, how soon this can become a practical source of energy, I have no idea. Mm-hmm. But with proper funding and application of intelligence, it shouldn't be in the indefinite future. I expect it to happen.
This has been a really interesting discussion. We've moved from intro to technology and societal benefits. I really appreciate it.
It's been a pleasure.
We hope you've enjoyed part 2 of our conversation with Dr. Imre Gyuk. Join us in part 3 as we wrap up our discussion. The Tech Between Us podcast is included in Mouser's in-depth look at green energy storage systems. To learn more, explore the entire Empowering Innovation Together content series at mouser.com/empowering-innovation and explore articles, videos, use cases, and more.
Providing cutting-edge components for the progress and development of engineering solutions worldwide. Panasonic's products enable solutions across a wide set of applications for automotive, EV charging, battery storage, and more. Visit mouser.com/Panasonic.